everyone. Let me fix the desktop. It just broke. Okay, so everyone, how's it going? I'm Professor Caudill, and we're picking up where we left off in vectors. So last time we did an attempt at this example. I think we're kind of close. So in my mind, I was reading it as like four dogs holding the rope, pulling it this way, and one super strong dog pulling it that way. So, um, obviously the book has it a little differently. It's got different angles. Um, I guess in some, if when you add these, it should give you something like this one. Um, so let's see how the book does it. We assume east is that, okay. So we have to break down ABC into components. So we have to find the resultant, and then take the negative, and that's D. So pretty easy. So again, we were kind of close. So let's see what's important here. So we're trying to find R, and that is components AX plus BX plus CX I hat J hat. So you're basically taking magnitude times cosine angle for all values. So AX is the magnitude of A. So that's going to be this X. So if he pulls it 160 units, A goes 160, then that should be 160 times cosine. So south of east, so that should be negative 55. So they're getting 91.8 newtons. So let's see if our calculator is right. So 160 times cosine negative 55. And this should be 90, right? 91. Okay. I've had to mess with this a little bit. Okay, it's not right either. Specify cosine function, specify so we've already done something similar to that. I just wish it was kind of built in. I guess we can copy some of this. So what's our angle? -55. So magnitude is 160. Angle degrees. So that, yeah, Senpai is doing times degree and didn't even specify a degree, so I don't know what this will output. Yes, should be like that. Or I just do this. Cosine, angle degrees, cosine 55. We wanted this. And we want our magnitude times this. So now in the future, we should just be able to plug all these in and get 91 degrees. Okay. So our calculator is working. So it should be 91 plus 173. So it should be 91.8 newtons plus 173.2 newtons plus -114.7 I, and then you do the same for the y's. So that's what they did here, 150 and 49. So R is 150 and 49, but you want it negative because it's going in the opposite direction to make it a zero net force. So it'll be negative 150 minus 49. So now we have the components. So if we have uh, negative one, negative 49, and negative 150, and we have some hypotenuse. This, we can drop it down. This forms a right angle. We can add Pythagoras theorem. So 150 squared plus negative 49 49 is 158. Okay, so now they want to know so you can either do it like this or you can do it like this. So if you did it the long way, it's going to be this angle. So it seems like they always do tangent, even if you know all the angles. So what's opposite of this angle? That's negative 49. And so we're using TOA for tangent function. So tangent theta is 49 over negative 150. And these turn into positives because you're dividing by negatives. Negative, like a negative times a negative is a positive. And you take the inverse. Okay. Let's call this calculate magnitude of so the recent angle is negative 49 negative 150 so no magnitude. I might have butchered that spelling. So cosine, I'm sorry, this would be a tan this over this. So we're getting something quite not 18 degrees. So what is going on here? Okay, I see what I did. We did not convert it to, we did not convert it from degrees to radians. We're still not getting that. Fix this. No. 1.2. Um, Angle in degrees. Okay, so I like this little if stand. So 250. Okay, so what is it saying? It's saying 180 degrees plus, what is that, 70? So let's look. Does this make sense? It's 70. Um, okay, another way of saying it is this would be negative 90. And then we want to go negative 360 minus 90, 270. So what's left here? If you have 250, 20 degrees. So I don't know if this is really matching up with the book. Oh, there it is, 20 degrees. Yeah, so that should work. Add a feature that calculates the negative angle. But we're building this because more than likely we'll reuse this. So, that's not really what I'm wanting. I am getting okay, yeah. So this makes more sense. Convert the negative angle of northeast. So north to west is 270 minus negative angle. So that's not right either. It should just be 90. All right, so maybe we're trying to do too much. So so this A10-2, that might have fixed what we were doing earlier. That prevents dividing by 0. Is 250 degrees the same as 20 degrees southwest? All right, let's draw a picture. So we want to go, this is 180. And our calculator is giving us 250 degrees. So that's going to be 180 and then 70. Okay, and there's 90 degrees. So that's going to be about 20. Again, we're estimating here. So, and then there's 90. So 180 plus 70 is 250. So like we're right, but I do want to know if direction is great less than 0. Add. Okay. I guess we could do this minus 360 minus this. Negative 108. Okay. 360 minus that, minus 90 degrees. Southwest, and then we get 18 degrees. So that's our answer. We had to really mess with it though. So let's say degrees and southwest. Print. I know we've been always spending a lot more time coding than on the book, but again, I'm confident we'll use these tools later. Degrees. All right, so all right, we can move on, I think. Suppose Balto leaves the game to 10 more matters. So okay, so we are just doing the same thing, but with so again, A plus C minus D equals 0, or A plus C equals R and R minus D equals 0. Okay, so what do we need? Same numbers. So a d plus r equals 0. Yeah, there, that fixes it. Okay, so a. All right, so we want to find r. R is so ax so 91.8 plus cx and ay cy plus 80 j. Okay, so we have 91.8 minus so plus 80.3 negative 50. All right. So we have our components. So now we need to find the magnitude of A, magnitude of R, or we could just go ahead and find, what is it asking exactly? Step full, okay, so negative D, so D equals negative R, so D equals 22.9 plus 50.8. So these are the components of Doug's. All right, so we want to find the magnitude of D. That would be square root 22.9 squared plus 50.8 squared. Um, given so A equals 20.9, B equals um Okay. $55.8. Okay, so now we want to know what direction this is in. So we're going to take the inverse tangent of, so I'm imagining all this in quadrant 1, so our x component is 22.9. So that would be opposite. No, that would be, so this would be opposite. So it would be y, so it would be 50.8. 22.9. So we're getting 24 degrees. Sounds about right. So do we answer the question? How big a force in what direction must Doug pull in the new toy to balance out? So Doug must pull 55 newtons. So Doug pulls 55 newtons at 24 degrees. I don't know if it's convention, if it's like you're supposed to say northeast, northwest. Um, so I'm just gonna say 24 degrees. I guess since we're on a plane, we should say northeast. I guess it is courteous. Does that, I mean, it only makes it clearer, you know? I mean, and when it gets 3 dimensions, I guess that gets a little trickier as well. So the forces were, um, that's D, and then this should be R. All right, I think we need to move on. Good exercise. Find the magnitude of vector C. So find C. and B is negative j hat plus k hat 2. Okay, so we got a lot of information here. First solve the given equations for unknown c. So okay, and substitute. Okay, so solve for c. So all right, so that should make it easier. I just figured out I can scroll on this. So we shouldn't have to erase all the time. So what do we have here? 3, we have C is 2 j hat minus 2 times vector A plus 6 times vector B over 3. So we just want C in components. So C is 1/3. So this should be in three dimensions. K is the unit vector and the z-axis plus 6 okay, so that's our equation. I guess we can draw it out. Minus 6 j hat all right, so that should be 3. Okay, C is, so we're gonna add the j's, so negative 1/3 over, let's see, 2 plus negative 6, negative 4 j hat minus 2 I hat plus 7 k hat all right, and I'm gonna write these in XYZ form. Negative 2/3 I hat minus 4/3 j hat plus 7/3 k hat. Okay. There is our vector C in component form. Now we want magnitude. So to find the magnitude of C, it's going to be so we need to find the components. So Cx is going to be Alright, so we need to know magnitude. So -2/3. Would it just be cosine 1? Hmm. What is the direction of -2/3 I hat? So 180 degrees. Okay, so I remember the book would write it like this, -I hat. Maybe it's more intuitive when you do that. So this is saying we're going a magnitude 2/3 this direction. 2/3. And then we're going, so if we had to draw this is your Z axis, this is your Y, this is your X. What we're saying is we're going 2/3 this way. So we are going, this vector is going this way, this component. And then we're going, I'm sorry, this is a positive X, so we would be going the other way. 2/3. And we would be going this way, 4/3. And we would be going up 7/3. So we want to find the vector that's going something like this. That's your C. It's going in that direction. So how do we find that? First, we need to find the magnitude. So let's go ahead and calculate that. So 4/3, 2/3. So 2.7. So C equals 2 point, let's say 8. Okay. So have we answered the question? I want to find the direction of this, but I don't know if it's asking for that. We got the components of C. We have C, so okay, so let's Sorry. Let's just see what the book's doing here. See if anything we've done has. Okay, so 2/3, 4/3, 7/3. Doing good. 23/3. 24/3 is 8. 14, 24 is 8. So that's asking for the square root of 8. 3 square root of 9 is 3, so yeah, 2.8. So yeah, I would be a little tough to find the direction of this. I could see a way where you're like taking the tangent of the xy, and then you take the tangent, the inverse, take the inverse tangent of the xy coordinates, and then you take the tangent of like the xz coordinates, and then you might be able to do something like that where you're describing this angle on the xy plane. So I don't know, is there, that might be a good question for the chat bot. When describing the direction of a vector in R3, you use 2 degrees. So yeah, you would use phi. Phi would be the xy. So this would be phi. No, would that be psi? I think that's phi. Phi. Okay, my bad. Phi, phi, phi. So yeah, xy is phi, and then the inclination theta is this from positive. So that's theta from the xy, so the azimuth, and then the inclination. So we have, so yeah, we're kind of close, I would say. All right, so starting at a ski. So I wonder if I can just kind of drag infinitely. I think so. That's pretty nice. So move on. Starting at a ski lodge. Cross country skier goes 5 north. So he's going, let's say, cross country skier. Let's just say C is 5. I'm sorry. He's going 3 west, so that would be negative I hat plus 5 J. Okay, my bad. So he's going this, and then he's going. All right, I'm sorry. 5. I thought it was describing 3 dimensions. They want it in, it's just a 1 dimension, so it moves. So he's going 5 kilometers north. So 5 I, then 3 west. And then 4 southwest. So that's negative I, negative J. So this is west-south, but it's southwest. Okay. Find his total displacement vector. So how far did he move? Okay, well he has moved. Um, so I guess another way of writing this. Hmm. Okay, so the book likes to do the angles, I guess. So yeah, we can just say move 1 equals 5. 5 in the 5 kilometers 90 degrees. All right, so this is just another way. So we need to find. Do we need to find the magnitude of each? I think. All right. So 5 cosine 90. So that is the magnitude. Uh, yeah, the magnitude of move 1. Hmm. I don't want to waste too much time, so I'm gonna stick close to the book here. So yeah, maybe I should draw a picture. So 5, 3, 4. So it's asking how far. It wants to know. Let's say this is our return vector. They want to know this and the direction of it. So remember, vectors have a magnitude and a direction. So we need to know the magnitude of r and the direction of r. So I'm not sure. This might not be 180 exactly. Just heads up. So they convert So they have 3 vectors. So the first vector, move 1 is so I guess I could say it's 5 cosine 90 degrees plus because I'm taking these are 2 vectors and you can add 2 vectors to get another vector. So I think this notation is right. So move 2 is 3 move 3 is 4, so southwest. So what did the book do? So it's 180 plus 45 is what the book's saying. So it's saying 180 plus 45. So they're saying this is, I mean, so this, so 225 is the same as I, J. Okay, so cosine 225 plus, okay, so okay, so we are going 5, we're going 90. I guess I should swap these. Angle degrees in degrees, magnitude is 5. Where are you going? 590. So equals 0 plus 5. Okay, so this should be J. So we're going 0 in the X direction, or we're going 5 in the Y direction. M2 is 3, 180, So is 3 in the I direction plus 0 in the J direction. And then 4. Okay. And this matches up with the book. We're out of time, but 2.8 negative I plus 2.8 negative J. So so R is going to be M1 plus, so it's gotta be negative, right? So it's gotta be R plus M1 2 3 equals 0. So it's gonna be the negative of all these. So we'll pick up where we left off next time. And I kind of want to just finish it, so maybe we can. Components. So R is going to be negative. We're gonna take everything to the negative. It's gonna be negative. So it's gonna be 5 negative J plus 3 negative I plus 2.8 I plus 2.8 J. Okay. So we can convert these negative 5. So with this should be negative 1.2, 1.2, negative 1.2. They're not getting that. So what do we do wrong? So okay, so that should be 2.2. Zero 0.2 I. Three. So this I must have messed up a sign here. 5.8 kilometers. All right, so magnitude is okay, and then you take the tangent. So it's going to be your y over x So tangent -1 of 2.2 over -5.8. All right, so they had to convert this is where they converted it to negative. Southeast, so like that. All right, so notice that no figure is needed to solve this problem. All right, so next time we'll pick up at 2.13. All right, thank you guys.